All right, so we're going to start right away. No wasting of time. Like I normally do, try to keep to time. Uh, I'm sure that people that will join later will refer to the recording. Thank you very much, ladies and gentlemen. We're going to continue from where we stopped, you know, last time. Today we are going to handle the rest of the D. Okay, so that next week we start with the A, application and operations. So we've talked about inputs and outputs, which is get and retrieve. We extensively dealt with CPU, talking about the processing. If I have to go back to the slides just to show you something so that I can picture some of the things that we did the other time. So as just a way of recapping, we talked about machine cycle, what happens. The three components of the processor is the control unit, the ALU, arithmetic logic unit, and the main memory. And the major cycle that happens there is what we call FDES, a cycle of fetching information or command from the memory, decoding it by the control unit, and then the ALU executes it. And the output is equally what's stored in the memory, from where it is either executed to an IO or maybe sent to permanently to what we call the secondary memory. Memory is always referred to as primary memory. So I remember I told you guys that this goes by different name: E cycle, I cycle, fetch code, FDES cycle, machine cycle, whatever cycle it is. You know now that we are dealing with time, so that's why the idea of time is important in processing. And I know I mentioned you know, how these things are done. All the line you're seeing here is what we refer to as buses. I talked about data bus, address bus, and so on and so forth. So they have the motherboard, the CPU, the arithmetic. So all these components communicate with each other, and because there is a need for us to control the way information flows in the system, there is a need for process states. Okay, so the states I know we refer to as a new state is like a new command that is currently generated, and sometimes it has to queue and get ready, and then it is run. And sometimes it's depending on the algorithm you are using, it might be paused and be waiting, or the running might conclusively determine the output, and then the cycle is terminated. So we talked about all those things. Each cycle will have what we call PCB. Um, PCB have different components, right? You have the ID of the process itself. Of course, every process will have an ID. Okay, you equally have process states. I mentioned whether it's ready, is new, is waiting. So it will have that kind of information. Then it has counters, then CPU register. That's the memory information. We are going to talk about register today. Then the priority and then memory management information. So we look at different uh, ways this control unit will help the CPU to function. So you can see some of those functions will include starting and suspending. Look at that task one. And he called up task two and suspended it again and called up task three. While he's doing task three, the task one that was suspended was called upon again to continue. You can see. So this is what we call remember we talk about multi-threading, instead of just dealing with one and allowing and maintaining every other person, every other listing on the key. So there are different algorithms that is applied. And remember, I talked about FIFO. FIFO is first in, first out. You're going to see FIFO and LIFO when we talk about critical thinking, and problem solving. At that point, you're going to deal with algorithm and data structures. What we are not there yet. So this is actually algorithm. So you have FIFO, first in, first out. It's more like a queue. When you queue up, it is the first person that is attended to and the last person that we attended to last. So they are not the call shortest job. It's another algorithm that takes the shortest job and executes it. Of wasting all the time doing one job is not optimal. You do the short ones and then devote time to the long ones. They have what called round robin. No matter how long or short or this, all he does is take his equity. He takes one information. So all these algorithms will work in different scenario, but you just need to know them. Um, so we talked about process scheduling. Whether it's ready on the queue, whether there's a job on the queue and then device. So you remember I mentioned I/O. Whenever I hear of I/O, it means input output. So the way you write your program, the way your program responds, also know that everything you attach to the system like a peripheral, equally uses the resources of the system. So ever wonder why when you are moving your mouse, it's responding, you see the mouse moving on the screen. It's actually a command, it's part of the ones and zeros we are talking about. So we talked about thread, thread is like the smallest unit of an instruction that is good, that will share register and stack. Register, we're going to, I mentioned register last time, but today, that is what we are here for. After this recap, we're going to talk about this. So it will have its own register. Then multiple threads could equally share. Why they are having their own register and stack, they can equally share across board the codes, the data, and the file. So that's what they call multi-threading. I told you an instruction can be distributed in such a way that it brings equity instead of allowing others to be on the queue and finishing all of them before you go over to the other one. So the difference between multi-threading and multiprocessing is the multiprocessing does not share code. A process has its own code, its own data, and its own file. Look at the illustration there. But three of those threads can share the same code, the same data, and the same file. So that's the difference between multi-process and multi-threading. So I talked about I/O. Input devices equally has a way of content. That's why when you plug your flash, either I say the system will recognize a flash immediately. So it's part of the instruction that is going to. So the brain does a lot of things. You are watching movie, meanwhile connecting a hard drive. I want to download want to transfer another movie from. You are using your earpiece to listen to the music. All these things, okay, they are equally taking resources from the system. So looked at some of the listing I operations. I don't want to go dwell into this before I start confusing you. So that was where we actually stopped last week. So this week we are going to look at memories, that storage, memories and all that. So let's begin. So the primary memory is what we're going to start off with, right? Remember I said there are two types of memory, primary and secondary. Primary is the main memory of the system. Okay, when you are buying a phone, they say what's the memory, say 2 gig RAM, 3 gig RAM and everything. That's where information are stored temporarily while working with the brain of the system, which is the CPU, right? A memory is just like, let me read what is here. A memory is just like a human brain. It is used to store data and instruction. Simple. We know our memory is the whatever is intended in the definition of our memory is what the computer equally adopts as the definition, the computer world. So memory, computer memory is the storage space in the system where data is to be processed and instruction required for processing are stored. So where data to be processed are stored, as well as the instruction needed to process the data. So it's not only storing data, it equally stores instruction, right? Memory is largely divided into, cells, Like if you look at these diagrams, and you see something like look like a grid, small, 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 so they call it location, memory location. You know, when you are storing something on your hard drive, what happens is that is actually goes to that hard drive and take up is a lot of depending on the size of the file, you take up the memory, allocated to it. We are going to come to data structure very soon. Okay, we are going to have linked lists. You see how these things are connected. That is why most of the time, if and these things disjointedly, you might be having issues later. So if you just follow this class gradually where it's going, it will be better for you. So memories are basically divided into two. If you look at that diagram, there you have the main memory and then you have the secondary memory, right? So the main memory is the primary memory, right? It's divided into two, RAM and ROM. Okay, so the RAM is the random access memory. That's the meaning. So you see something like SRAM and DRAM. SRAM simply means static. This simply means dynamic. Okay, so static and dynamic. Do I bother to explain it? Okay, let me just talk about it. Right, they are both type of RAMs. Okay, used in computing. But they differ significantly in different things. Like they don't have the same structure, they don't have the same speed, they don't have the same cost, they don't consume the same power, and they are not used for the same thing. So something like a DRAM might have like a one transistor, or one capacitor per bit. But an SRAM can have up to six transistors per bit. DRAM, they are usually, of course, from what I just mentioned now, you are expecting them to be slower, but SRAM, they are faster. Okay. DRAM is cheaper. That's where the thing gets flipped. This thing is the SRAM is expensive. So DRAM is dynamic in nature. You have every other thing like the volatility, the density, the data. How power consumption, yes, and also I've mentioned cost before. So please, this is not for you to cram. Oh, there are two types of RAM, SRAM and DRAM. All you need to know is that um whenever you see SRAM is is static RAM. D is dynamic. Okay. So we have ROM. ROM is read-only memory. Okay. It's ROM now is no longer only, let me make it clear because some of the time this thing can be confusing. It's no longer only primary memory. Before now, it used to be considered as one of the primary memory storages. But as time goes on, in today's slide, we are going to see something. You see the reason why I'm saying so. Okay. Um, we are going to look at it, bit by bit, right? I'm going to play a video. So, okay, I think I have to reshare my slide so that I can equally share sound as well. Okay, so I'm going to stop sharing because we are going to, I will share again with audio this time. Share sound, okay. Sorry, I'm sharing the wrong screen. So, okay. All right, so we have please can someone confirm that my screen is now visible? And please tell me what you are seeing on the screen. I have two screens here, so I need some confirmation.
I
Am I
only see
audible?
one screen, the one with memory.
Oh, okay, okay, okay. Thank you. All right, so let me continue. So ROM is read-only memory. Let me to make it simple because I don't want to confuse people. Whenever you hear ROM, just remember your disk. Simple. There's no don't overthink it. Remember your disk. I'm sure most of you that are using very sleek laptop now, they will remove that. You won't see the disk where you can slot in your disk. This is simply like a plastic that rotates. That's what they call disk. So their technology, it started from CD. CD is called compact disc. Then from CD it moved to DVD, digital video. No, no, I'll find out. I think it's on the slide. Then we move to uh, Blu-ray disc and all that. Now, before now, why is considered wrong? Okay. Meanwhile, some of these things that I are seeing, PROM, EROM, let me just mention it too. This simply means programmable read-only memory. Okay. The other one I are seeing is erasable programmable read-only memory. The other one, EE, is electrically erasable programmable ROM. So that's it. Okay. I just want to limit the scope because there are certain things I start going into volatility. But ROM, you bought it once permanently. Use when data never changes. The other one, it can be erased using ultraviolet lights and all that. That's the EPROM. Okay. This thing. The other one is easily electrically erased and programmable. So this is not why we are here. Nobody's going to ask you tomorrow what is pure. I want you to really understand what storage is all about. Okay. Now, if you go to the other end, okay, let me mention why I said it is no longer only primary memory that's all this ROM. Remember, in the days you only have CD. The first technology that actually revolutionized the idea of ROM was the CD. Okay, compact disc. So compact disc mostly were only read only. Okay, and sometimes they are used to run some programs and all that. As time goes on, they develop DVD and even readable. So at some point, sorry, writable. Okay. They now develop another type of disk that you can rewrite. Okay. Before then, when you want to buy an album, you buy maybe Plantation Boys album, they have one, two, three, Style Plus and all that. So all those things here in compact disc, you cannot buy the album and go and change the content that is inside. But along the line, we started having DVD that people can actually store things, delete things. So at the end, you can consider those ones as what? Secondary memory. Okay. You're even going to see more like a Blu-ray disc here. That is the idea. As far as you can store information, erase it, delete it, create a new one, that particular device is no longer just primary memory. It is now a secondary memory because you are using it to store information. When they say permanently, what it means is that if you don't touch it, it is going to remain there. Any day you bring it up, it's going to, come up on that. Unlike RAM is temporary. That's why if you are working and there's an power outage, you lose whatever you are doing because everything you are handling at that point is still in the RAM level. So let us go to the secondary memory now. Secondary memory, there are a lot of them. We are going to talk about secondary memories today, because today is storage, But for us to understand what happens in the CPU, let's look at different types of memory. Okay. Sometimes you hear register, sometimes you hear cache. Somebody might be having problem with his phone. They'll tell you to clear your cache. You know, Today we are going to talk about that cache that somebody is trying to expecting you to clear so that you have things. So look at this diagram that you have. Okay, the diagram you have, it shows register the smallest. You can see the parts in red are memory locations that has already been occupied by data. The parts in blue are yet to be occupied by data. So when we say, memory are small cells, that's what we meant. Okay, you can see you have what we call the register. Register is the smallest. The way it is arranged on the slide is the way it is according to their sizes. So register is the smallest, cache is the next, then the main one we call RAM is the next. Then finally you have your secondary storage, which we are going to dwell on today. Okay. So within the CPU, you're going to have two, like the register and the cache. So you can see level one and level two in this slide, but remember, sometimes you might have level one, level two, level three, level four, depending on the configuration. So don't cram that, oh, cache only has level one and level two, right? So you can see that register is filled, like everything is red. So register, let's go to the next slide so that we can begin to treat some of these things. Okay. Now let us look at cache, right? Now, what does cache do? Let me explain to you people the idea of cache. Cache is a memory location that is close and always available to the CPU. So, for instance, let me give you an example of some of you have used cache, and you are, cache is something that helps all of us. Now, you're on Facebook, right? And somehow your data finishes. You will notice that when you open Facebook, it, it does not automatically give you error like you don't have data. Somehow you see some things, So companies now, have decided that it is too harsh for somebody to just come into a platform and you see error 404, So they will give you something, right? Now, when you click on facebook.com, something will appear like Facebook and some posts and everything. Do you know what's happening? It is taking the information not from the internet, it is the cache that stored that information. So cache is a memory space where things like that could be stored. It's only when you click on a button and now want to enter, you will not see that error because you are not actually connected to the internet. So that's what cache does, you understand? Even when you browse and probably you shut down your browser and everything, you come up again, you see something like you want to restore your previous listing. What are you restoring? You're restoring information that is stored in the browser cache. So why people ask you to clear your cache is if you begin to have a problem, it is possible that that particular application had a cache that had that error. So whenever you click on it, the first thing it opens is the cache that contains the error. So you'll be wondering what's going on, and someone will advise you maybe you need to restart. You see, the truth is that restarting all this is just to clear some of this cache because why cache is advantageous also. You know that in some cases when you're having error, the cache you call it going to see this because the cache does not look at it does not know which one is which, so it's just garbage in, garbage out. So cache memory is a very high speed semiconductor memory which can speed up the CPU. Of course, it's close to CPU. It acts as a buffer, yes, it acts as a buffer between the CPU and the main memory. So you can see it's like an intermediate. It will hold some data and actually determine when to release some of those data and information. So advantage of cache. Cache memory is faster than memory. It consumes less access, okay, less access time as compared to what the access time that main memory consumes. It stores the program that can be executed within a short period of time. It stores data for temporary use. I remember I told you people about women selling kiosks and the way they arrange their things. It's caching. You understand? So that when you want to come and ask, they don't need to get up. They make sure that the things that you are going to, they make sure that most of the things that are asked often, they are close by so that they can actually stretch out hand and get them. So the disadvantage of cache memory, it has limited, of course, now is inexpensive, is very expensive. So look at that diagram below, the bottom right, okay? If you are working, you are accessing a server and there is no cache, right? You can see what we are looking for might take 240 milliseconds. But look at the other one. If there is a cache, then the cache is closer to the visitor. So the visitor can easily access what is in the cache. And you can see there's a difference of 200 milliseconds in terms of response. That's huge when you compare it with very, very large amounts of data transfer. Let us talk about register. This register is the smallest. Register is the smallest use of smallest and fastest memory. The computer, is allocated to the CPU. Of course, it's close to the CPU. What I'm trying to say is that register are just used for quick access, store, and transfer of data. Like I said, it's still following that principle. Okay, so there are a lot of memories. There is one that has to do with data, small memory that will hold data, small memory that will hold process instruction, register, input and output characters and all that, even accumulated processes as well. Okay, so there's one that can hold address as well, address register. So this is just memory. I just have to touch it. Okay. Now, there has been an evolution. We are not going to the secondary memory, evolution of storage devices from the 80s up to what we have today. Okay. I am going to play a video for you. I'm going to play the video. Just listen to the video, right? And then you see how where we are coming from and where we are today. I need to play the video now. Go to the next slide. Okay. So I hope the audio, because that's what I set up there.
The beginning of data storage dates back to antiquity, where our ancestors stored information on cave walls, then on papyrus, parchment, and paper. Let's see how data storage started and evolved.
Was it audible before I continue?
Yes, it was
Yes,
audible, sir.
sir.
Okay.
Punch cards were the first official form of data storage. These were pieces of perforated. The beginning of data storage dates back to antiquity, where our ancestors stored information on cave walls, then on papyrus, parchment, and paper. Let's see how data storage started and evolved. Punch cards were the first official form of data storage. These were pieces of perforated paper where the holes are 1 and the non-holes are 0, being inserted into the computer by photoelectric scanning. In 1890, Herman Hollerith invented the tabulation machine using these cards, which could read and record data up to 0.12 kilobytes.
So this is mechanical way of storing information. Right? You see something that looks like a typewriter, they didn't need electricity. So even before the ENIAC that I showed you, if you remember I talked about mechanical. So you see, this is coming to bear now. It's used to store information in a certain way. That punch they are seeing there can equally be referred to as the 1 and 0 that we use the transistor to demonstrate at that point. So sorry, what happened? Okay, let's continue.
Perforated paper where the holes are 1 and the non-holes are 0, being inserted into the computer by photoelectric scanning. In 1890, Herman Hollerith invented the tabulation machine using these cards, which could read and record data up to 0.12 kilobytes. In 1951, magnetic tapes began to be used to store data on a computer. A 225 kilobyte magnetic strip could replace 1,920 punch cards. In 1956, IBM invented the world's first hard drive and weighed about a ton. It had 50 24-inch disks, a rotation speed of 12,000 RPM, and could store up to 5 megabytes of data. Specifically, such a hard drive could replace 23 magnetic tapes. After that, in 1963, Philips Company released cassette tape, used mainly to store audio files. A small 90-minute tape could record approximately 0.66 megabytes of data on each side. In 1971, IBM introduced floppy disks or hard disk alternatives. At first, there were 8-inch floppy disks with a storage capacity of 0.8 megabytes, but later a smaller version of 5.25 inches appeared, which could store 1.2 megabytes. The 3.5-inch floppy disk was introduced in 1982, was the most popular, and could store 1.44 megabytes. Also in that period, 1980, Seagate released the first 5.25-inch hard drive with the same structure as today. It weighed 2.3 kilograms and could store 5 megabytes of data. In 1982, Sony and Philips released the compact disc to store information in digital format, especially audio recordings. The CD storage capacity was 700 megabytes. In 1991, SanDisk released the first commercial SSD with a storage capacity of 20 megabytes. The largest SSD is currently 100 terabytes and costs over $40,000. In 1994, iOmega introduced Zip Drive with a capacity of 100 megabytes, then 250 megabytes, and 750 megabytes. In 1995, Sony, Philips, Toshiba, and Panasonic introduced DVDs. It has a larger storage capacity than the same size CD. A DVD could store 4.7 gigabytes of multimedia data. In 1999, Panasonic, Toshiba, and SanDisk developed a 8 megabyte SD card. Back then, the SD card was used primarily to store music and photos. In 1999, M-System developed the first USB flash drive, a plug-and-play data storage device. The first USB flash had a storage capacity of 8 megabytes, gradually increasing the storage capacity even to 1 terabyte. In 2006, Dell, Hitachi, Hewlett-Packard, LG, Mitsubishi, Panasonic, Sony, and TDK developed Blu-ray disc, a high-definition data technology. A Blu-ray disc can store 25 gigabytes or 50 gigabytes of data. The concept of cloud computing really began to be discovered in 2006 when Amazon launched AWS, Amazon Web Services. Google Drive is the most used cloud storage service in the world with a percentage of 94.4%, followed by Dropbox with 66.2% and OneDrive with 39.35%. By 2025, there will be over 100 zettabytes of data storage in the cloud. If you don't know how much a zettabyte means, we have a video explaining this. You can find it in the description. Thanks for watching.
All right, so that's a brief. So you can see most of the things you've used, even those that you did not meet. Depending on the generation you are born, that would determine the one you met. So that's not the main. This I just want you to understand where we are coming from. You can see has been improvement over the years from magnetic, to disk, from disk to what we have today. And I'm going to talk about all this, including cloud. So let's just go ahead. Now, the storage that device you should know, okay, the one that is relevant to us. So the history has been told, but let us look at it. Today, you're going to be hearing HDD and SSD. What does that really mean? The answer is there on the screen, okay? HDD is hard disk drive and SSD is solid state drive. The difference is that the hard disk drive, there is a disk inside. That's what you see that is rotating there. And the rotation has memory. Each of them, they have a sector, according to the circumference and all that. You can write, on the memory, and you can read from the memory. So this is like just your turntable. There's no difference. So it's the same thing. You want to play, Oliver the Cook, that year that my father used to store a lot of them, and all these olden days musicians, Alex O and so on and so forth. Even Chris Okotie, they used to have all these things. So you see the head, they call it turntable. It will be shifting and changing position from the inner diameter to the outer diameter. So that's how the memory is the same principle that runs this hard disk. So when you buy a system that have a hard disk drive inside, when you put it on, you hear one sound like that. So there are two sounds you are hearing. There's sound of the fan as well, and then there's sound of the disk itself, because they are both, rotational motion. So they both exhibit rotational motion. But if you are using a hard disk, you see nothing is rotating there. It's simply made up of chips inside it, that can hold information. That's why it's called solid state, because it is static. It's not dynamic. It's not rotating like the hard disk drive. So last thing you need to know is external. So once you talk about external, sorry, my screen has stopped sharing. Why? Okay, hold on. Let me share my screen again. Sorry about that. So when you hear external, right, it simply means both hard disk drive or SSD. So it could be SSD or SD, but it will be attached to the it will be attached to the it will be attached to the computer as a peripheral. Okay, so remember the definition of peripheral. See, this thing does not want to leave us. It's going to continue, right? Some of these terms will follow us to the end, right? So hard disk now is going to be attached using USB. We are going to talk about USB actually in this call today. So having talked about it, it's simply just either HDD or SSD that can be attached to your system as a peripheral. Now we have the next word is what? The next word is flash drive. Flash drive is a solid state drive because nothing is rotating. So you can begin to see other types of solid states. So USB is the connector, right? Flash drive is the storage device. So we're going to talk about USB very soon. Then we'll have the memory cards. Okay, you have a lot of sizes and capacity. So you have full SD, full memory card. You have mini, you have micro. I think most of us are using micro in our phones today because they've improved upon the resources. Sorry, the technology. I hardly see, except those that still have the old digital camera. I know I use this big one very, very well. And I think also the professional camera guys you still have slots for uh, full SD. But what they do now is even if they have the slots, they now have like an adapter where you can connect your micro or mini and you still be able to connect it to the camera like that. So of course people are aware of the nano smart chip, like the MTN, what we call SIM card. There is mini, there is micro, and they have jackets, something I will not call it jacket, like a compartment where you can put it to fit into any phone. So if it is the phone that is using the old method, you have to wear everything. So that's how the memory card, you can see different size is there: 16 gig, 4 gig, 64 2 terabytes. I remember I told you people where those numbers, why they chose to use specific numbers like 2 gig, 32, 16, 8, 128, and all that. So let's go to this. So this went from compact disc to DVD and now Blu-ray disc. Just improvement on the resources. Okay. Now let's go to what is beginning to become like a private cloud. So this is what they call network attached storage, right? NAS. Now, there's nothing special about this NAS. If you check the one that is open, if you look very well, you see that it is the HDD that is coming out from there. So I have how many compartments? 1, 2, 3, 4, 5. So what it means is that assuming I do a lot of work that consumes a lot of information and a lot of data. Example is a photographer. Okay, I take a lot of photos and all that. So I don't want every time I take photo, I will just go remove uh, the SD card that is there, remove the photo, rush back, put it. You might miss some important things, even those that shoot movies as well. So for you to do that, the people that are smart came up with this idea of network attached storage, meaning that this storage now is like a small server. So assuming I have 4 terabytes, right? Into 1, 2, 3, 4, 5. 4 times 5 is 20 terabytes. So if I put 4 terabytes worth of disk in, so I will have 20 terabytes. And it's not just the storage. Okay, this particular machine, right, can equally has USB that you can use to transfer. If you shoot movies or maybe take pictures, you can attach your this thing and transfer it directly to the disk. Now, the important thing here is you'll be asking yourself, why is the name network attached storage? And the reason and the simple answer is that it is connected to the network. Sometimes you choose to use wireless network, which can be connected over a long distance, which is what we call internet today. So what the thing special about this thing is that I can stay anywhere in the world and be transferring information to this thing at home because it will have its own modem. It's able to connect to the internet and it is live. Okay. So having said that, let us now go to what is happening today. Okay. You now have difference between SSD and SSD. Okay, let us look at the similarities both on the left, on the right hand side here. They are both used to store data, of course. Okay. They are both used to boot the system. Now, if you buy a new system, of course, you don't have any OS. In some cases, a brand new system, you don't have any OS. It is external this thing that you use as peripherals connect to the system and boot it, and then probably use it to install the OS that the system will be running on. So they are both, they can be used for I/O input and output. Of course, I've talked about external hard drive. So difference between SSD and HDD. The main difference between solid state and this thing is how data is stored and accessed. Simple, and HDD is a traditional storage device. Yes, it's old, that uses mechanical spinning platter, okay, and a moving read-write head to access data. SSDs are newer, faster, you know, they can do a lot of quick or processes and operation, right? That is why most laptops you are seeing today are going for SDD. In fact, when you are buying a laptop, you check the spec, you're either going to see HDD or you're going to see SSD. Most of the laptops you're going to be buying today is going to come with what? An SSD. I'm sure that very soon HDD might feel but it's still being used. So, all right. I'm not going to dwell on this. Let's talk about cloud, right? So, you see, while we are doing all these things, you see this video that we just watched. Things keep improving from megabyte, giga. Now we have 1 terabyte, we have 2 terabytes worth of storage devices. We even have 6 terabytes, a lot of all those very interesting things. Well, guess what? Human beings, we are all insatiable. I will use myself as an example. I had a laptop, my laptop was almost getting filled up. I bought an external drive for 1 terabyte. That one is filled up. I have another one 500, it's almost filled up. You could see now, if I am limited, I might have been forced to go to the first one and see what is that I don't need and just remove them. But because man is insatiable by nature, we just keep everything and keep on acquiring. That's the greed in us. So by the time you're acquiring all these things, at the end of the day, you might have everything filled up. So, the IT world also notices the same thing. Even if they build the best, maybe they are building the wrong products. All right, they kept, there's a way we look at this world and see the trajectory. Am I not selling? Am I not trying to produce something that is already outdated? So, like, okay, why not move this information? Why can't people buy spaces in cloud and store some of these things? So of having to buy external hard drive, buy flash and everything, all of a sudden things get filled up. So how did this whole idea of cloud computing come in? Please listen to this very, very well. Nobody should confuse you. The cloud, as you see it, is not something that scientists woke up one day and say, let us invent this or let us pursue this. There is a company called Amazon. Listen to this story. What Amazon was doing, they were selling books. Okay? They were selling books online. So they were simply merchants, e-commerce platform that you can sell books. So what happened is that the server they were using got filled up, right? They needed to put more books on this thing. They have a way of doing preview and all that. The storage device they wanted to use got filled up. They have to start looking for other vendors. They collect other. So the more that they collect vendors, the more thing gets filled up. So you say, hold on, if we are looking for this particular service, only God knows how many other people are looking for that particular service. So why not start building data center? Now they are building data center, but they are building a data center with a difference. Now I'm going to tell you why it's different. The data center you are building now, you are building it specifically for people to come and ask you to lend them spaces, right? So they called it merchant.com. Okay, if you follow the story, it was not Amazon, it was called merchant.com, where if I am now selling, I can equally come to that platform and set up, my own interface, and then I'll start selling and all that. So, of course, that one will come with, its own downs. It has ups and downs and everything. So, what Amazon do is they sell to people, they started saying, wait a minute, wait a minute. These people don't come to us to come and buy these things, right? We allocate memories to them and they pay for it. That was when the spark came. They said, come on, we're missing something. Let's build more of these things so that we can sell to people, remotely. Like, I want to store my picture. You give me a space where I can store my picture secured, so that when I come back tomorrow, I will be able to access it. That made a whole lot of sense, right? So on-demand delivery of computing resources, such as, you can look at the slide now. You need the server. Gone, 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 gone. There are no two ways about it. Of course, the storage is running on the server. I embody it because we're talking about storage today. There are other aspects of cloud computing I'm not going to touch today. The database also is going to be shared. We need the database, network, storage, and analysis. Guys, these things are listed in red here, right? Can I get them over the internet? That was how cloud computing was born. They now metamorphose from that merchant.com. They call themselves Amazon Web Service. You see, there's an Amazon that sold book. There's AWS now. So Amazon Web Service started this whole idea. This idea is what eventually was referred to as cloud computing. You see how cloud computing did not come from a research lab, it came from Amazon, and they should take that credit for it. So what cloud computing means that, okay, there's this mobile, look at this slide, there's this mobile app, there's this laptop, there's this printer. All of them can be routed over the internet to have information from the server, virtual desktop, software platform, application, storage, and everything. Okay, so you can use desktop, you can use switch to access. So now there was no need, okay, of clients coming to see. For all you need to do is go online. You're going to see all the systems that they have. You will rent their system online. When you click, okay, I need EC2 instance, I need it for 5 days to do something. They will give you for you, they will do the calculation. You pay for 5 days. When you are done, you go. So that was how this whole idea of cloud computing came. When you hear cloud, it's not in the cloud. Cloud is simply a data center somewhere. Okay. So I will not talk about this cloud, even though I will not talk about, I'm mentioning web 1, web 2, and then I'm hearing we are already on web 3.0, right? So I want to draw an analogy how we shifted from, there's no difference between cloud and server, but I'm going to tell you how we shifted from using the name just server and knowing when to use cloud and when to use server. Okay, so when we were in web 1.0, right, all the website that existed there was more like a large, let me call it a very large version of Wikipedia. You search, it brings information out, you take it, you read it. You understand? Go and check. Everybody should Google Web 1.0 and Web 2.0, how we kind of transited to where we are today. So the 2.0 now brought about the idea of application online. That is why you can do financial transaction. It was not there before now. Okay, with MTN becoming, more reliable and all that, with other networks, you can actually, access information via the internet. You can even rent a system that is better than your own, and you sit in the comfort of your home and work on that. You can boot the system, but the system is not physically existing. but you can use it. We have used it also this year, right? I'm going to just refer to some of the things that it has been used for. Now, it allows users, that's the last sentence there, it allows users, to access and manage computing resources. Please mark these specific terms I'm using. Computing resources. When you talk about cloud computing, the simple definition of cloud computing is that someone, okay, can access resources, computing resources remotely. Simple. Ability to access computing resources based on demand is what we call cloud computing. You understand? So, while we have all these apps and everything, you need to equally pay attention, to the market. So the remote accessing of all these things was what gave birth to Amazon Web Service. Amazon started growing. When the thing was so obvious, Microsoft started their own. They called it Azure. Okay, Azure is the cloud platform for Microsoft. Then Google have what they call GCP, Google Cloud. I can't remember what the P stands for. GCP, Google Cloud something. So now let's explain it. Okay, guys, just listen to me carefully, right? Look at this slide. If you don't understand cloud computing in this slide, you're never going to understand it again. Okay, follow me, follow this story. Look at the picture on the top left-hand side. Just pay attention to what is there. The components of those pictures are the same, but the coloration are different as we move from left to right. So let me go to premises, right? Okay. The best way I can describe premises is the laptop you're using to watch me or the phone you're using to watch me is in your premise, right? And that phone or the laptop you're using to watch me now has networking, it has storage, it has server, it has virtualization, it has OS, you have the middleware, runtime, data, and application. Of course, you are the one that is managing all these things. If your screen goes by, you're going to repair the screen. If your CPU goes back, you're going to repair it. If there's an attack, you're the one that's going to maintain everything because the laptop is in your hand. If armed robbers see you on the way and take that laptop, you're not going to sue anybody. You understand? If you pour water on your laptop and probably there's a static electricity and something, you burn something, the responsibility is in you. That is why the color is totally orange. Orange is saying you manage. Look at, there's an inscription towards the left-hand side of that. You see, you manage, right? So the orange color is the one you manage. The green color is the one somebody manages for you. So let us go to the second part of it. Okay, you have IaaS is called infrastructure as a service. That service is written in green there. It is those ones. So somebody is giving, instead of you worrying about it yourself, somebody has decided to take up the responsibility and offer you that service. So the person is giving you, an infrastructure that has networking, storage, servers, and virtualization. I'm going to talk about virtualization in the next operational application very well. So let's go to the other one, PaaS. It means that somebody also, in addition to what they offered in the infrastructure as a service, infrastructure is simply the hardware that will enable you to do the networking, the storage, the server, and the virtualization. But somebody will say, no, it's not just the hardware. What if the person doesn't have an OS? You can see the platform as a service. Let's give him an OS. Let's give him a middleware. Let's give him a runtime. Runtime is simply coding. So in that case now, you see, it stops at runtime so that programmers can actually use it to develop their own. Okay, it is called platform as a service, right? They are providing you a platform for you to create technology products on the cloud. Okay, so the last one now is software as a service. You don't care about, like now, if you're using Google Map, You cannot come out today and say, how does this thing work? It's none of your business. You are using that Google. Google Map is software. Google is offering it to you as a service. So when you use bots and all those kind of things, you are not coding, right? But some people want to improve the process. There's what I call key developers, you understand? They'll keep on improving on the process. They are not going to be using SAS. They are going to be using PAAS. They are going to look at the platform. They are going to build their technology on the platform because you have provided everything that the platform needs for a tech person to be able to work around it, okay? But this other one, those that are using Canva, if you are using CapCut, if you are using any online tool, what you are doing is simply what? You are doing software, you are using the software, and the owner of the software is giving it to you as a service. So let me do an analogy that will make sense here, right? If I am operating from right to left this time around, where you have SAAS, right? If you look at the diagram by Saturo on the right hand side, they didn't put on premise. I'm going to talk about it now. You see SAAS, consume, PAAS, build, IaaS, you host, right? Let's talk about consume. The nearest thing that makes sense I want to use for this is pizza. If you walk into any place where they produce pizza, right? Your interest as at that time is for you to pay for pizza and they give you the pizza. Now, I want to introduce the concept. Everybody listen to me now. I want to introduce the concept of abstraction. And I'm going to use this thing to treat what abstraction is so that if you see it tomorrow, you don't say, which one be abstraction again? It is very simple. And most of the time, it is the explanation of this thing that is complicated, right? Now, I'm going to use that um, um, pizza to explain abstraction. Abstraction is certain processes, right, that have been organized in such a way that you don't have to bother about them. Separation of concerns, right? So, let's talk about pizza. I have separated the people that are selling the pizza have separated the concern from the client, meaning that I don't care where the market where the floor. I don't even care about the farm where the flour they are using for the pizza is coming from. It's none of my business. So they've abstracted the whole process to the point where over the counter, I just want to pay and buy pizza. Ladies and gentlemen, there is no pizza in the world that did not come from a farm. Take it or you leave it. There is no meat pie you have ever eaten. There is no rice. There's nothing you go to a fast food to do that does not come from a farm. But it's none of your business to start looking for which farm did this particular rice come out from before I eat it. Rice that they don't cook finish, they see fried rice and they don't fry. You can't ask. You just say, okay, do you people have fried rice? They say yes. You pay for it and they give you coke and chicken. You go and sit down and eat it. You understand? I don't think there's anybody that will say, is he your father? Is he Babaki rice? Is he this one? Okay, that is one. They have abstracted the whole process for you so that you focus on the one that is important to you. That is separation of concern. Okay, you guys know that if you leave the farm, it doesn't go straight to Kilimanjaro or Chicken Republic. It goes through a lot of processing. Okay, you go to the factory, you process it and all that. Another level of what? Abstraction. I don't care. Let them process it the way they want to process it. The next level also is after processing it, they go to the market to sell the flour. And then the guy that is going to buy the flour goes to market, buys it. But remember, before the person goes to market, if it is a corporate organization like Chicken Republic and all that, guess what? The board will have to meet, accountants have to do, so all those processes will have to take place. So the purchase is not just, oh, you order for it and it came. Those processes is what you are saving the person. Then when you even purchase it, there's what they call inventory. They will take inventory, you hand over the procurement officer, hand over that to the warehouse guy. The warehouse guy will pack all the floors, know when he is going to release for this particular department that makes bread, and the other department that makes meat pie, another department that makes different things. You understand? So again, I don't care. It's none of my business. Abstraction. Now, I can equally eat pizza. Listen carefully. By going to the market and buying the flour and making it in my own kitchen. Even though I did not care about how you got to that market and the farm it came from and the processes you will do, I am taking a responsibility that the other guy that is in the shop buying the real pizza doesn't want to take. So I am buying the flour. I want to go to my kitchen. I want to probably play around on how to and learn how to do pizza and everything. I'm still going to eat pizza, but at this point now I'm taking some of the responsibilities that this other guy does not want to take. Okay. Now, another thing I can do is that I can equally buy the flour, right, to my house because I have a nice cook. Listen, follow this story. I have a nice cook that can actually make the pizza, right? So I buy the flour myself, but when I go to the house, I don't care. I just hand over the flour to the cook and say, I need pizza by 7 p.m. This evening. The cook says, yes, sir. And then 7 p.m., the pizza is ready. Have you seen it now? So what I am trying to show now that at some point, there are level of abstraction. If I have children at that point, the children does not want to ask me, Daddy, which market did you buy the pizza from? But me, I had to concern myself. I have to drive, I have to do all those things. Now, what we are talking about cloud, let me take Shell, for instance, or Chevron, any of the oil and gas companies, right? Shell has, of course, they will have a data center. So I want to link it to what we call on-premise. That is what you are seeing up there, top left-hand side. When you hear on-premise, it means that the data center is on the premises of the owner. That's why I use your laptop as an example. Your laptop is with you. If you need to put internet, now you go put internet. OS. If you want to install runtime, runtime simply means if you are doing an Android, some of you that are going to be using VS Code, that VS Code is the runtime. You cannot write code without putting something like a NetBeans, VS Code, what there are other IDEs, Android Studio. There are a lot of them. So what you are doing is that it is now your responsibility. You don't say you want to have the laptop. Yes. Before you write a code, HTML or CSS, you have to go and get the VS Code, which is the runtime. What you are seeing there on the screen, that's the runtime. You put it, you install it in your system before you build the code. So you are the one that is setting up the platform for yourself. You are not handing it over to somebody else. So with this, the way I'm explaining it, you see that it is simple to really understand this whole thing rather than confuse someone. So what some of these guys are doing now is some businesses will give you infrastructure as a service. What it means that they will give what they call bare metal. If you are hearing it for the first time, you can note it, you can write it down, you can check it out later. Bare metal means they are giving you raw system that has everything that it takes for you to install your OS. Look at that second, you can see the only way you start from is OS. They're not going to give you OS, right? This is over the internet. To remember, when we're talking about cloud, is over the internet, meaning it is no longer yours. So immediately you leave premises, that 2, 3, 4 is now we are talking about cloud. We are talking about the internet. Internet is what makes the cloud. So, but another person can say, don't worry, let us install OS for this guy now, even give a runtime. Let him just write his code. I hope that this now is becoming simpler than the bogus explanation that probably we have heard before now. So when this happens, now you begin to use it the way. So there are companies that play on the premise. So back to the Shell story. Guess what? First of all, they'll have to map out one part of their compound, maybe premise. They have 20 hectares, they might map out a space here and say they're going to build a data center there. That's one. They are going to call a surveyor. They are going to clear the site. Just follow the story. They are going to clear the site. They are going to lay the foundation for the building of the data center. They are going to start construction. While they are construction, after construction, okay, remember, you are not constructing a house, you are constructing a data center. The question is, what is going to be inside the data center? The answer is simple: servers, networking gears, accessories, and everything. Okay, you will build house, roof farm and everything. You still place order for the servers. Maybe there are 40 of them. Apart from placing order for example, you place order of HVAC, humidity. HVAC is just air condition. Let me just put it like that. Air condition, HVAC, air condition, humidity V. I can't remember what is V and air condition. So anyway, I forget about it. What I'm trying to say is that every single furniture that is going to be used there, you have to equally import. Now, when you are importing now, what is the complexity? There will be a procurement value, supply chain. You are going to ship it in, just like you have Jumia, you have to wait and all that. Okay, when the thing comes in, remember we're talking about your premises. Okay. Oh, okay. I have stopped displaying. Okay, just give me a second. Okay, sorry, the screen will be back up very soon. I just have power outage, so let me just continue. I think you can follow the story is not about the screen. So what I was saying is that after building this whole thing, you wait to they supply the thing. You don't have to go and call professionals to come and install. After installing, guess what? You are going to employ IT staff. And when you employ IT staff, you are going to pay them salaries and they are going to manage the equipment on premises. So remember, keep the story going. It's on premises. Then when you pay them, you have to bring in security as well to maintain the whole place. And then building management system and all that. Probably sometimes you need to check whether the air conditions are working and all that. Now, I want people to understand why cloud computing is very important. So imagine if you look at another person come to tell your guy, don't worry, you know what, I'm going to that data center you wanted to build. How many just tell me the capacity again. Say it's supposed to be like 2 zettabytes of it and of storage, this one of this thing. So it's okay, no problem, I'll give it to you. Are you serious? Say how? He said, go out to our website, www.this thing, open your account. When you open your account, go check this, check that, and then it is going to come up online. Wow. You see, all these stories I've told now, you don't even need to do any of them anymore because somebody has taken that responsibility. And all you need to do is to log in via internet and you can actually provision the resources that you just mentioned. And that resources, the networking, okay, the compute and the storage. These are the most important resources that when we're talking about compute resources. So why have I been killing myself all those why? Now let me tell you what is happening, right? What is happening is that a company like Amazon, this is where it gets interesting. A company like Amazon Web Service, okay, had decided to do what? They have decided that they are going to build a very large building. The same thing that you did in your premises. So they are going to replicate the same thing, but now they are building it for almost everybody. Okay, they are going to use the same money. They are going to employ their own security, IT, and everything. Nobody is supposed to come to that location. Like now, I can go to their website and buy exactly the number of computers I want to buy. Okay, let me share my screen. The power is back up. All right. So I'm supposed to now just anyway. Can anybody, is the screen visible? Someone should confirm.
It's trying to load. It's visible now.
Okay. All right. Okay. So we have someone that will take up all these things and do it. So let me tell the business model now. I am the business model now is that I am A, and the person that is supplying me this thing is Mr. B. Now, there are other people like me, like C, D, E, B, like we are like four. So the sense here is that these are four of us building different data centers in our own premises because we want to, do secure our information and use servers. This person thought it wise to build a big data center and rent to us whatever we could have built in our own. So we are saving, all those overhead and even the time. Like I said, I'll go to their website and get those things now. Just imagine how long it would have taken me to build this data center. So anything that has advantage has disadvantage. You understand? But the thing is that in cloud, you cannot buy. You can only rent, okay? As long as you want. It's pay as you go if you want to rent. Because sometimes when you even build your big data center, you might just be using one server rack and others will lay waste and nothing will happen. And sometimes you get filled up before you get another one, you're already overflown by information. So this is why it is good for you to now relinquish that thing. So cloud computing is all about division of labor. Okay. I don't want to bother myself. That's why I say like it's just like eating pizza. I just want to get information, get a secure place where I can store my information, put all those things there, and they will take care of this thing. So that is what happens. So when you have an on-premise, it is called a private cloud, right? You can now see where I'm going to. Public cloud is when you give all the distance to someone, right? To manage for you. Okay, if somebody's managing your visualization, your server, your storage, your networking, and all that. So somebody's managing it. So that is public. Is now you are not in charge of it. Private means that you is in your premises. Okay. Let me equally mention there are some private clouds that are not really on your premises. There are modifications to some of this nomenclature. There are some people that will say, okay, let me come. Okay, I'll come to your data center. You show me rack A to rack D. I say, shut it down for me. I am the only one that wants to use that. Even though it's not on my premises, it is still a private cloud because I have decided to shut it. Nobody, okay, will be allocated any space in that. And I can connect to it through a secure channel. They call it virtual private cloud, VPN, VPC, sorry, virtual private cloud, VPC. So that is one thing you need to know. But hybrid now is what a lot of people are going for. Hybrid is a combination of private cloud and public cloud. Now, example, a bank might decide to say that some information will not go outside our own data center, but there's some information that we can allow, like transaction amount and all those kind of things. But some of these things will retain. So what they do is that when you are doing some transaction, okay, and you need that information in within their listing, the security that they have will make sure that you really, really deserve to have that information before they give it to you. Then when you get the information, you can now continue your transaction on the public cloud. So a lot of health companies, hospitals, they don't really release everything on the cloud. So they still have a hybrid. So when you hear these things, you see how simple as it is. It's not very complicated. So they combine the hybrid and all that. So that is what happens, in this whole model. Okay. So whenever you are using Google Team, whenever you are using Google Meet, Zoom, and everything, remember you are using software as a service. You don't provide any of these things. So, but you can pay to use what people have already developed for it. So let us concretely, talk about the cloud itself. Okay. Um, so let us talk about clouds. This is what we are talking about. Okay. So can you see the screen? I just want to confirm. Someone should just chat
Yes,
on the
yes,
chat.
yes.
Okay,
Yes, I
so
can.
now when you hear cloud, for a company like Amazon, this is what it looks like. Okay, the places with green dots is what we refer to as a region. Remember, we are still talking about storage now, but we won't talk about storage when we don't tell you about the future. I can't stop by telling you flash drive, hard drive, and everything. This is where everybody is going. So you guys need to understand it very, very well. And some of you that might do DevOps will now, people will now appreciate this thing very well when you go deeper into the DevOps. So the one with the green dot is what we refer to as a region. The one with the red dot is a region that is coming. Maybe they are still under construction. So all these things you hear cloud, that is it here. You are looking, especially as far as Amazon is concerned. This is the data centers that we are talking about. This is where you can go, sit down in your comfort of your room as you are there, log into Amazon, buy some credits, and go there and buy a computer. You can choose the computer that is 16 gig RAM, blah, 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 and you have it. You can use your own laptop to access the system. You can build anything you want to build on it. You keep on renting it until your rent expires. You understand? It is your own. Nobody can tamper with it. Instead of you going to buy a laptop, placing order on it and everything, that is what we call cloud computing. That's why that word computing is there. So you're actually reaching out to do that. So Amazon was the first, and actually they have the highest share in this market, more than this thing in this market. Again, okay. Guess what? I have to share my full screen. My light keeps tripping off. Hold on. All right, so this is Amazon. So let's go to the next one. The next company that does this kind of thing is also Google Clouds. Okay, so Google Clouds provider, that's DeepCP. What Google Cloud does is equal to do the same thing. They will provide all these things. So you can see that this is similar to the diagram you just saw. You can see they're almost locating this thing in the same places. In Africa, it's only in Johannesburg. Let me go back to this thing. The same thing. So, guys, Nigeria, what is happening? Okay. What is happening? Well, you don't have power. That's the truth, because data center consume a lot of power. And your power should not go off. I don't think you have ever gone to Netflix. They say Netflix is not available because the data center is down. Data center is always available. I remember the line I drew when we talked about the internet. We're going to talk about it also later. You see, the line is not here, but it's actually these lines that cross across to meet all these data centers that is making up what we refer to as internet. So you can see, notably Africa is this thing. So this is Another big company that is investing, you can see the dot is current region. They are using triangle for upcoming, or the other people call it upcoming. They called it future region within, this thing. So I'm going to talk about region also. So they have networks and everything, So they even added the name of the cities where these data centers are built by Google. The next company that is playing very well here is also Microsoft. You can see their own nomenclature, available region, announced region. So announced, upcoming, future, everything the same thing. Again, South Africa, they have two there. Every other place in Africa, none. So this is this thing. So let's just now visualize what we are talking about. If Nigeria is a country, this is what we mean by region. One of those dots is represented like this, right? So when they talk about region, within the region, they normally have what we call availability zones, which is in a region, you will have all those dots you see, they have like 3 or 4 data centers within it, and that's what they call availability zone. So look at it now. Assume we have a data center in Abuja, in Enugu, and in Lagos, okay? That will make up a region. That's what they call a region. So if you can actually zoom into some of those small circles you're seeing, you see that they've built huge data centers in each location. Do you know why they are always a triangle? It's because of redundancy. Assuming trailer or shack chop the connection between Abuja and Enugu, Enugu can still connect to Abuja through Lagos. That is the idea. Okay, I hope you understand. It's very easy to listen. So that is why in a region is always, three, because of what disaster recovery. You can replicate stuff. If anything happens to Abuja, it is retained in Lagos and all that. So you can see to run this data center is not easy. I give respect to the companies that run it. So this is exactly what we are talking about. So of course, that's the legend there. The region is the circle, the availability zone is the distance. So for those that are going to go more into cloud computing, you are going to see some of these things. So it is beyond, the scope of this lesson. So let's just stick to the scope, right? This is just defining region and availability zone. So now, this is what we are talking about. After looking at it on the map and everything, guys, this is one availability zone. And inside the availability zone, this is what inside looks like. So when you talk about cloud, it's not the other one you're seeing in the bottom right hand side though. Cloud is those buildings that you're seeing, made up of servers. This is the servers that are inside. This is the example of AZ. You can see I wrote AZ on top there. This is the availability zone. Okay, this is where all the Netflix movies, all the YouTube videos are stored. Those that are putting off channel, I have a channel, I have a channel. Anything that happens to this data center, your channel is gone. No, it will never be traced. But these players know how to actually, maintain their customer. You are not their customer. The customer is YouTube. Of course, that's Google. Their information should never be tampered with. You are just a user. A YouTuber is just, you are using YouTube. That's a software as a service, right? So I want all these things to be clear to us in simple terms and no ambiguity, right? So having said that, let's talk about the memory. When we're talking about memory, okay, remember we've talked about bit. Bit is simply the smallest unit of information. But when we talk about data, it becomes a different thing. Now, if you cast your mind back when we are doing A, B, C, D, ones and zeros and everything, remember you needed like maybe 8 boxes to make one character. And that 8 boxes is what we refer to as 1 byte. So when you have 1 bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, and eighth bit. When you combine all of them, it gives you 1 byte. Now, the truth is that the smallest unit of data is like a character, like A. So it doesn't make sense. I want to differentiate why sometimes they use bits and sometimes you use bytes, and where you actually use bits and where you actually use bytes. So it doesn't make sense for me to be saying, oh, my storage device is made up of 8 bits times 3. That is like ABC. Assuming the storage capacity is 3 characters, like A, B, and C. I will come and say my storage is 3 sets of 8 bits. Why not just say 3 bytes? That's the idea, right? So the bit is the smallest memory unit to measure data stored in the main memory. Okay? Of course, and other storage devices. A bit can only have one binary value, which is either 1 or 0. Remember, I told you the box, yes. The box is only one thing that can be inside that box, either 1 or 0. We are not talking of a byte, is fundamental unit for measuring data. So it contains 8 bits. Okay. So or 8 bits is equal to 8 bits. That's simple. So now when you talk about terabyte, gigabyte, is only a multiple of all these things, right? So it is easier if you look at what I had there on the other side of the triangle, the left hand side, you see kilo, mega, giga. What it simply means is that you have a bit. Enable is simply half of a byte, like 4 bits. A byte is 8 bits. Now, when you talk about kilobytes, right? Kilo means 1,000 what? Bytes. Kilobytes. When you put mega, mega is what? 1,000,000 bytes. When you say giga, giga is simply what? 1 billion bytes. When you say 1 tera is 1 trillion bytes. When you say petabytes, petabyte is what? 1 quadrillion bytes. And it goes like that. Exabyte, zettabyte, yottabyte. Remember, in one of the videos, they say in very soon, the internet will contain about 100 million zettabytes. That you can see the amount of information that we are generating. When we talk about information management, that is we are going to look at all these things. Okay. So, having said that, the last part of this, we are going to talk about hardware before we just touch software. Okay, hardware, we're going to look at the motherboard, right? The motherboard is where all the buses and all the components are connected. And we need to look at some of them, okay? So the motherboard serves as a single platform to connect all of the parts of a computer together because everything works together, right? So there has to be something that will carry everything. I've shown you, how the buses connect every single component here. But we need to talk about the motherboard. The motherboard connects the CPU, the memory, the hard drive, the optical drive, the video card, the sound card, and every single thing. It can be considered as the backbone of the computer. And you know, normally when I teach this class physically, I usually bring a physical step, but I don't know how to do that here. All I can do is to show you guys with a diagram. Okay, I think that's fair enough. Okay, um, with the diagram, I am now pushed to start breaking things down. So let's go ahead. I'm going to try. So we have what we call physical ports, right? Before we go into what is the physical port. Now, some part of the motherboard is that you must have where the power is coming from. This is an electronic device. It cannot come up without power. Either your battery is dead or something is wrong. It cannot boot, okay? So you're going to have different things. Some of these ports is what we're going to explain. We have talked about the RAM, I have talked about the memory, I've talked about the ROM and everything. So let's look at these ports. There's what they call the Ethernet port. You're going to, some of you look at your laptop now that you're using, you're going to see something like this. Especially the RJ45 is very common. When you buy a router, maybe Airtel router, in fact, if you're using a router now, the big router, you look at the back, you see this kind of connection there. You understand? RJ45 is modem. RJ14 is outdated. RJ45 is one that is used. All of them are used to connect to internet, mostly modem. Whenever you hear modem is any component that connects you to the internet. So when you buy your Wi-Fi, they call it a Wi-Fi router, MiFi router. See, that is a modem. The correct word for it is a modem. It can also be a router. Why? Because that modem that connects to the internet can also connect to different devices wirelessly. Okay, like your MiFi. That is what makes it a router. Okay, because it routes information from the internet to your phone as well, and from your phone to the internet. So, but that connection to the internet is referred to as modem. Please, I don't want you to mistake these terms. Know it and know it well. Okay. So RJ45 is for connecting this thing to the internet. So let us look at some other peripheral. Most of these peripheral, you are not really going to see it on your laptops, or you're going to see it on very huge traditional desktops. Okay, there are PC/2 ports. Of course, the one that is purple is usually the old connection for keyboard, and the one that is green is the old connection for mouse. And some people still use it up to today, but today we have USB. We are going to talk about USB very soon. You have serial ports, parallel ports, and gaming ports. Remember, your VGA connects to this thing using your VGA cable. Some of these things are outdated. The old games like Nintendo and all that uses some of these ports, right? Um, but I have to mention them. It is for connecting peripherals. The serial port is mostly used for connecting to the monitor. They equally what we call audio jacks. So the audio jacks, of course, people will know when you have your stereo in your house, you have left, right, and all those kinds of stereo in, stereo out, and center woofer and all that. Even the stereo in your house still uses this pattern. Even though the connection is now looking more like the RJ/14. So you have that A/PDIF. That's everybody knows what we call earpiece. These are the kind of, so most laptops usually have that connection, okay? And then we have what we call digital audio connection as well. So they can be seen in home theaters. This is mainly audio ports. So remember, I'm using the word, I'm introducing some terms gradually. I'm not introducing all of them at the same time. So when you hear ports, it's actually used to connect peripherals to your device. So let us go through them and see how we have moved from VGA to DVI to HDMI and then USB. You can see all these things, these things, they have connection, they are not disjointed. So you need to understand what is going on. Even when you go to church, you connect your screen and everything. So the first one is called the video graphics array. That's what we call VGA, VGA, VGA. You see it most often, I showed it here, serial ports, okay? It's used to connect monitors, mostly graphics. So there are some televisions that still have this VGA. So after this class, what I want you to be doing, I want you to be practicalizing. Go around and be checking people's laptop whether they have this thing. Okay. If you want to feel funny, you just say, this is VGA. Do you know what VGA means? Everybody knows, but they don't know the full meaning. Let me tell you the full meaning of VGA. It means video graphics array. Just to say, wow, this is interesting. So it is actually an analog interface, okay, between the PC and the monitor. There are some monitors that still use this for the VGA cable. Then they moved toward DVI that didn't really last. DVI is what we call digital visual interface. You understand? That is developed by a group called Digital Display Working Group. You understand? But it did not last because VGA still was more accessible to interoperable devices. Interoperable devices means you can use it in different connections, like I don't know if you are familiar with projector, okay, projector screens and all that. Most of them use VGA. So you will see that most systems that has a lot of desktop actually have this. If you check your desktop at home now, you surprised that you have it. So in this case, they support both digital and analog video signals, right? Yeah. So what has happened now is that we have gone on to what we call HDMI, high definition multimedia interface. That's the full meaning of HDMI. Is mainly digital now. In fact, most of our decoders, including DSTV decoders, are now using HDMI. This class I'm having, I'm displaying it on the screen using HDMI cable. There are different HDMI cables, but I'm going to talk about it very soon. The other display ports, like the name is actually display ports, is a digital audio video connection. Some system have it. I think my old system has that, but I think this thing is outdated. Ladies and gentlemen, let us focus on USB because we have moved from various technologies. And why did we call this USB and what exactly do they mean? USB. So USB means universal serial bus. The name implies that it is universal, okay? And remember bus, okay? And this sign that you see here, some people, I don't know what they look at it, but what their sign shows that it is going to be used to connect to different things. So different things is represented by a triangle, a square, and a circle. So one thing can be used to connect to different things. That's the concept of this logo. So USB logo, any USB device, you see this logo on it. So USB is a standard. I want us to understand it. Because of this, look at this slide. This slide looks messy. Why can't we unite all this instead of having different standards and call it universal? I hope you are following the story. So when we call it universal, we'll be able to do a lot of things with the same ports, right? Now, it is what the most commonly used port now, and it is what universal. What is the goal? The goal of to make one standard connection. You understand? Making connected devices easy to configure and provide fast transfer rates. Now, when you have your USB, what you are going to do is you just connect it to your system. Remember, if you check very well, if you are following trend of things, you can use the same port to connect to your printer, use it to connect to your scanner, use it to connect to your flash, use it to connect to your phone. So you can see it can connect to different things. This is what is showing in this slide. Your camera, your keyboard, your mouse, your router, your printer, your scanner, and everything. So that is the idea, okay? So they produce this technology, but guess what? It's equally used for what? Charging. Now, USB now, in addition to transfer of data, okay, they have equally built it for transfer of what? The first USB was not used for charging, but when it was brought, I said, why can't you equally use it for what? Charging. That is why some of your phones now use USB, right? So let us talk about different standards of USB, versions of USB. A lot of people don't know that there are versions. And if you pay close attention to this, you are going to see that there are different colors as well. And let's all start from number one. The first one, they call it USB 1.0. Okay, it transmits 1.5 megabits per second. Remember, we're not using megabytes. Megabits, that's the number of ones and zeros. Okay, it can transmit is 1 million in a, no, 1.5 million in a second. The other one, 1.1, USB 1.1 can transmit 12 million bits in a second. The USB 2.0 version can transmit 480 million bits per second. Okay. Then 3.0, look at the jump from 2.0 to 3.0. USB can transmit 5 billion bits in a second. Then we move to 3.1, it can transmit 10 billion bits per second. Is it billion? Yes, it's billion. So USB 3.2, 20 gig is 20 billion bits per second. And then USB 4. You can see that USB 4 is transmitting 40. Look at where we are coming from. We are coming from 1.5 million bits per second to 40 billion bits per second. And that is what, ladies and gentlemen, we refer to today as Type C. Okay, let us go to that. So there are different types of USB connection. There is Type A. Type A is the one that you people actually call USB, but ladies and gentlemen, all of them are USB. If you are hearing it for the first time. So they have Type A, and then they have Type B, and they have Type C. If you look at this configuration, Okay, what type C tries to solve is what we call is a biological term. When you divide something into two identical half. Right. Okay, what it means is that I don't need to know the one that is up and the one that is down. So I can close my eye and plug type C. It's still a USB. Okay, I can go and plug type C. It's still a USB. So type A is one everybody knows, that connection everybody has, the one people actually call USB. So this is just to show different types. But this type B has different types. So we have type B, type mini B. Micro B is what people call flat pin. All these things will bypass them. Flat pin charger, that's what we call micro B. So it's actually a type B connector. Mini B is the one that old cameras use, Type B is the one that printer use. Okay. So you have type B 3.0, micro B 3.0. Micro B 3.0, some people that has this external hard drive that has something like it has this thing. If you have it, yes, that's micro B 3.0. Now we are in type C, and type C has taken over, right? In fact, these days we have type C to C. You have type C to type A. As in type C to C means it is C on both ends. Type A to type C means type A is on one end and while type C is on one, and that's the one that is commonly used today because of charger head. Okay, so this is C to C. Type C on one end and type C on the other end. Now I'm talking about the colors. Please, the colors differ whenever you buy your laptop. The color, they are not the same. Again, apart from laptop, charger, somebody will bring charger. Hey, do you have charger head? All you know is charger head. You don't even care about the color. As far as that thing can be plugged there, you plug it. This thing is not charging, it's not increasing. It has been in 1% since. Okay, it will be 1% because you don't actually know that is doing compatible with your phone. And it's good. This DAIPOD is exposing some of these things so that you know them. So when you see white, it means it's 1x. All the generation 1.0s, 1.0, 1.5, and all that. So black is USB 2.0. Deep blue is 3.0. Light blue is 3.1. Red is 3.2. Okay. Then when you see orange or yellow or something like that, it means that there's what they call sleep and charge. Sleep and charge means even if, like my system now, my system is not on, but once I plug my phone starts charging. It's not all, like you cannot plug a desktop that has been shut down and your phone will be charging. So that desktop, if you check the color, it will never be any of those orange or something because the technology has not been developed up to that level. Okay. So in general, newer USB standards, they are better, generally better. Type C, That's why a lot of phones now are going for Type C. If I let me even tell people, I hope people will know that they are forced Apple. Every Apple phone that will be coming out now will be using Type C. The battle has been won. They say you cannot be using your own standards, because before you know it now, it causes confusion that can never be changed. So Apple is going to go back to Type C. Any phone that they're producing now, you might want to check out the story, that I just talked about now. So having said that, we are gradually rounding off this part of it. The computer, remember we've talked about, is divided into hardware and software. We have exhausted everything, not everything, Sha. For this DAIPOD, we have exhausted the what? Software part of it. So, sorry, the hardware part of it. Let us now go to the software. This software will usher us into the second one. The second one, you remember, is DAIPOD. So DA, what we are doing now is DDA is application and operations. So we are going to do the intro to that one, using this so that we have a logical, seamless flow into that next week. So software basically is divided into two. You have software, system software, and application software. right? So, what is a computer software? Let us talk about it. Everything been talking about mostly is hardware, 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 hardware. Let's talk about software. When we use the computer, right? We use various programs. We use our keyboard to control certain things. We need to write codes, give instructions, and everything. You know, all these things, even though we are using hardware to do them, but the major thing about computer actually, when you're buying a computer, nobody's buying a computer to come and admire the hardware. That's the truth. Let the truth be told, right? You're buying computer because you want to use it for video editing. Software is the end goal. If there's anything like an end game, right? If I'm buying PS2, you understand? All the TV is going to help me do is to display what I want to play. All the game pad is to help me to enjoy the football, somebody passing ball to another person. You understand? So at the end of the day, software is the thing, right? So the hardware is an enabler for us to do a lot of things with the software. So when you want to classify the software, you classify them into three: system software and application software and utility software. Even though some utility software are considered under system software, I'm going to tell you the reason why, right? So computer software is defined as computer programming. Programming is simple instructions, which is which includes logical instruction employed for performing tasks using various devices on the computer. Now, if you divide it into two, what is the purpose of what? System software. System software is the software of the system, if you want to make it simple for you to understand. System software is designed to provide a platform for execution of computer program and to manage hardware resources. It acts as an interface between the hardware and the application. So system software is the baba, is the one that holds everything, connects your hardware and the other this thing. Unlike the application software, which is the what we actually use. So we have a lot of function for the system software. You can see why I said that utilities are always considered as part of system software, because we now have what we call operating system. So whenever you hear operating system, you are talking about the core component of that system, okay, that manages everything, every single thing, be it hardware resources, be it in the interface, be it facilitate the communication and all that. You probably have what we call device drivers. Now, drivers are, you know, they allow the operating system to communicate with the hardware. It's as simple as that. Like graphics card, the printer, the storage devices, it needs to be, the graphics. If you don't, provide the updated driver, your computer might malfunction. Now, why did I say utilities are normally classified under system software? Because they do similar things. Because utilities, you can't really say that they are applications, and you can't really say somehow that they are system software. But what do they do? Okay, they manage the system performance, that monitor like antivirus and protection and all that. So you can't call an antivirus like a system software. Something you can't equally call it an application, because you're not using antivirus for maybe playing game or doing anything like that. So the application software, the purpose of application software, right, is designed to perform specific tasks. For instance, spreadsheet, PowerPoint, and that's where we are going to dwell on the next lesson, right? The next lesson we are going to talk about application and operations. Okay. So operations mean operating system, application mean application system. That's how we transit from D to A. Examples like productive software. Please, I'm not doing this so that you cram. We are just going through this like a story. Productive softwares, like Microsoft PowerPoint, Excel, and so on and so forth. Media like Photoshop, photo editing, Canva, CapCut, and all those kind of things. Business software, enterprise, like Salesforce, Monday.com, Teams, and all that. Web browsers also are included in this. So we are going to dwell mainly on the system software in the first part of the next lecture. This is okay. Yeah, we are going to meet up with time. We are just in time. We have 10 minutes more. So operating system, we're going to talk about different operating. That's why I'm going to start the first lessons of the next edition. So I'm summarizing. We have gone through this journey of looking at all these things. I'm going to like look at them again in details. I don't want to confuse anybody by going to it. So the only thing I just want to end this lesson with is, let us ask ourselves a question. How are softwares developed? I'm sure developers are here, and I cannot end this session without really telling you what actually goes on. I need to bring back that idea of level of abstraction. Okay. Now, remember that the computer only understands ones and zeros. That is the hardware that sits on the bottom there. Okay. Then, what communicates to the hardware is what we call machine language. And machine language is simply one and zero. That's what we are trying to do, right? So, have you ever wondered how the Python that you write, can work with the hardware? So, there's what we call compilers and interpreters. So, the compilers are responsible to carry it from the high level language. So the high level language is what all of you on this call are going to learn, all the developers. Nobody is going to learn any low level language. So you need to know, when we talk about runtime is that platform that is provided for you. What does VS Code do? So that when you write your own, because what you if statement, if this one is that, while loop, because these are normal everyday English. That's what we call high level language. Python, JavaScript, this one and that one, C sharp, sorry, C sharp. So when you write them, okay, look at them here. So what happens? How does the system understand it? I have to mention it in this first listing. So what happens is that there is this high level language that you people are writing that has to be what assembled. There's what they call compiler and interpreter. So the compiler will compile it to the assembly language. The assembly language will translate it to what the machine language, which is the one and zero. So this brings the idea of abstraction that I mentioned at the beginning to fall. Guys, you don't have to bother yourself about how this one and zero is coming about. You need to bother about the syntax, and that's what you're going to be learning. But you need to understand what really normally happens. Okay. So if you concept of abstraction, if you write while n is greater than zero, sum equal to sum plus n and everything, this is what the coders write. That's the whole JavaScript, shell scripting, Visual Basics, and all that. So you see, the first and the last this thing goes through the same cycle. Okay, they go through that, what you call source code, from high level language into an interpreter. Interpreter will interpret it into, or compiler will compile it into what we call assembly language, and then the linker will link it to what we call binary language. Ladies and gentlemen, that's the abstraction. What are the most popular programming languages in the world today? And that's how I'm going to round off. Number one is Python, Java, JavaScript, C Sharp, C++, and PHP. Now, you guys know why we chose some of these programming languages. Okay, the other ones also in tiny script, like they're like TypeScript, Swift, Golang, Ruby, Kotlin, and others. Kotlin is, has been replaced, not replaced now. I think Flutterwave is more popular now to handle mobile. Ladies and gentlemen, coding, programming, and software development. I need you to pay attention to this last slide, okay? Because your job is threatened, and you have to move from 1 to 2, and you need to move from 2 to 3. Please don't give up. Anybody that is asking you to forget about it totally, that AI is doing everything, is not doing you good. Okay, they are trying to shut you off so that you hang all your thinking ability, hand it over to an AI to be thinking for you. So yes, the jobs of if you're just writing code, your job has already been taken. I have to be very brutally honest. By AI, if you give AI any instruction, even though it makes mistakes, but the speed the AI produces this result, man, is crazy. So you need to first of all still go through it. That's why I'm trying to encourage you people. Don't say, "Oh, AI is already doing it. I don't need to," because there's no way you get to become a software developer without passing through this thing. A code by definition is what coding refers to simply what an act of writing source code. That's it. The scope. Coding is a subset of programming. It's a subset of programming and software development. Yeah. So let us go to program. I want to rush this thing to the den to resolve it because I don't want to dwell on coding. Programming is the broader term that includes coding, but goes beyond it. It encompasses the entire process of software development. Yes, you need to think very well. When we come to critical thinking and problem solving, we are going to dwell on this. From initial problem solving, you need to be there. Design, testing, debugging, and maintenance. The scope of a programmer, it involves not only writing code but also planning, problem solving, and creating the overall structure and architecture of a software application. Then, software developer. Hello, can you hear me?
Yes, sir, we can hear you now.
Sorry, what did you hear last? I don't know where this thing went off. Where did you lose me?
Definition of programming.
Okay, I think I can summarize with this slide. So, coding is a specific art of writing code. Programming includes coding, but extends to the broader process of creating a software. Software development encompasses the entire life cycle of software creation, from conceptualization to maintenance. So, this brings us to the end of D for DAIPODS. We are going to enter A for application and operations next week. Thank you very much for listening. At this point, I hope I can. I don't know whether Ike is on the call or that I should just shut it down. I think I should just shut it down. So, yeah. Thank you very much. Thank you, everybody. See you same time next week. As we go through the journey, it's just for us to really understand this tech thing. It's not cast on stone. You just take your time. It makes your work easier because a lot of people want to scare you with this whole thing, but it's very simple. So, a sneak peek of next week. I still have 1 minute. Let me just share a screen to show you what we are going to be dealing with next week. So, give me a minute. So for week 2, we're going to be looking at operation of application of operations, just 30 seconds. So we are going to be looking at operating systems, looking at boot operations, what is kernel. We are going to look at the processes that happen in booting. We are going to probably use Windows more because I think Windows is more. I can't teach Windows and Mac and the Linux, so you have to take a standard. You need to go through some of these, some of these terms. Look at filing systems, so that none of these things will kind of confuse you tomorrow. Exploring and all that concept of pathway. We are going to look at this. We are going to do some CMD, just beginning part of it, just look at the settings that we can do. Go to command line interface, do some scripting, and all that. So let's stop here. I don't want to eat into your time. I think I've done enough already. So thank you very much. I will stop scaring now. Have a nice day, and let's see you guys next week. Bye. This is 1 after 4. I have another class. All right. Take care.